We first looked at graphing quadratic functions in vertex form, and now we're going to take a look at quadratic functions in factored form. Factored form is when it looks like a binomial times a binomial. Remember, at the very beginning of the year, we multiplied these together and converted it to the quadratic form. Now we're going to take a look at what the graph looks like when it's in factored form. We'll be looking for the same information on the quadratic function in factored form as we looked at it in vertex form. So our essential question is still, how do we interpret the graph of a quadratic function? Again, we'll start off by graphing on Desmos, and then we'll identify all of this essential information. So here I've got the graph of our first function, y equals quantity x plus 4 times the quantity x minus 2. So let's start identifying all of that important information that we want to know about this graph. First of all, those x-intercepts, where are we crossing the x-axis? We also need to know where the vertex of our quadratic function occurs, that turning point. We'll want to know the y-intercept, where our graph crosses the y-axis. First of all, a quick sketch. We had x-intercepts at -4, 0 and +2, 0. We had our y-intercept at -8, and that vertex was at -1, -9. All right, getting all of that information where it belongs down at the bottom as well. Those x-intercepts occurred at -4 and +2. The y-intercept was at -8. Our vertex, -1, -9, the turning point of the function. Domain for all quadratic functions is always all real numbers, so we don't have to think too much about that. The range has to do with the y-coordinate of the vertex and whether or not our graph opens up or down. The y-coordinate of our vertex is -9, and our graph opens up. So our range is y is greater than or equal to -9. Remember, if the graph opens down, it'll be less than or equal to. Now let's take a look at the equation and see if any of the information that we just found links to the equation at all. Our equation is x plus 4 times x minus 2, and our zeros, our x-intercepts, were at -4, the opposite, and +2, again the opposite. If you remember the asylum analogy when we looked at point-slope form for lines, that still applies to quadratic functions as well. If it's in the asylum grouped with the x, it's opposite from what you think. It's not normal. So it looks like a +4 in the equation. The 0 is actually a -4. We'll learn why that works when we get to solving our equations, but for now, if you think of that asylum analogy, you'll be able to find those intercepts fairly easily from just the equation. Taking a look at our next graph on Desmos. Notice that this graph is a little bit skinnier than the last graph because we have that coefficient of 2 this time. Let's find all of that essential information again. We're looking for our zeros. We're also looking for our y-intercept, where our graph crosses the y-axis, and of course that vertex, that turning point. Sketching that function. We had zeros at -1 and +3. Our y-intercept was at -6, and that vertex was at 1, -8. Again, those intercepts -1 and +3. The y-intercept was at -6. Our vertex was at 1, -8, that turning point of the function. Domain for all quadratic equations is always all real numbers. You can square everything. The range, looking for the y-coordinate of the vertex. And again, our graph opens up, so our range is greater than or equal to -8. One more time, let's take a look at that equation compared to our graph. We have a -3 in the asylum grouped with the x, so our 0 was +3. We have a +1 inside the asylum grouped with the x, so our 0 was -1. And one more graph. Notice this graph opens upside down, which we already knew because that leading coefficient was negative. So let's find all of that information again, starting with our zeros, our vertex, and we had to zoom out a little bit. That y-intercept is way down there on this graph. Sketching this function. That is not a very pretty looking parabola, but I was trying to hit that y-intercept, which was way down there at -32. Our vertex ended up being at 518, the turning point of our graph. Our zeros were at +8 and +2, which we already knew from the equation of our graph, the opposite of what we see inside those parentheses with the x. Getting that information organized, again, +2, +8 for our zeros. Y-intercept was way down at -32. Our vertex, our turning point, was at 518. Once again, domain for all quadratic functions is always all real numbers. That range, we need to find the y-coordinate of our vertex. This time our graph opens down, so our range will be less than or equal to 18. Here's your U-try question. Graph it with Desmos and identify that essential information from the graph.